Record. All right. So let's begin. Questions. Do I have any questions y'all want to go over? No? Everything's good? Y'all done finished the homework for today already? That's awesome. That is awesome. But it's easy though. It's easy though. Most of the answers are one, to be honest. No questions, everybody's straight. They are good prior to. I mean, the new homework, I didn't even show y'all how to do it yet, so. But it's easy though. I understand if most homework is easy. I get it. No pressure. I got you. Now the homework's easy though, I promise. Yeah. Yeah. Just adding, subtracting, multiplying. Yeah. I mean, even today, all we doing is adding, subtracting, multiplying, dividing. Yeah. The only thing is that we're gonna be doing it with big numbers or like really, really tiny numbers. That's it. Yeah. 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 Simple stuff. Yeah. Not from today's homework. I'm asking about like older homework. If y'all have any, I'm asking for like older homework if you guys have any questions. Yeah. Mm-hmm. So hold on. So you have 24 and 7 like this, and you want the vertical line going through it? All right. So which one is the vertical? Which one's the horizontal? Oh, y is horizontal, right? So look, let's say I have a graph that looks like this, right? This is my x, this is my y, right? So this is kind of a small graph, so just bear with me, right? Let's say that, for example, this was like the number 2. I'm just making it up, right? And then let's say up here, this is like the number, I don't know, 4, making that up, right? So this line right here, that's going down vertically, crosses which axis? The x-axis, right? So this is actually x equals 2. And then this horizontal line right here, that goes across. Well, that's really bad. Hold on. No, that's bad too. Hold on. Okay. I'm trying over here. That's why I didn't major in art. Right? So this crosses the y-axis, right? So this would be y equals 4. Right? So yeah. Any other questions? Also like x equals 24. or y equals 7. Like, yeah. Oh, second power. So like if I had like x squared, right? It would be x, and then you use the caret symbol, and then 2. The caret is like shift and the number 6, or command 6, I think. One of them. Yeah, yeah. Wait, say it again. X y plus 3. Okay, so y equals x plus 3, and I'm finding what? Oh, the x and the y intercept. All right. So your y-intercept, right, crosses the y-axis when x equals 0, like that, right? So that's the y-intercept. Your x-intercept crosses the x-axis when y equals 0. That makes sense, right? So long story short, plug it into the formula and then that's it. So like for the y-intercept, if I plug in 0 for x right here, right? Plugging in 0. Right? That's going to become what? Y of 0 is equal to 0 plus 3. Call that 3. So that would be your y-intercept, 0, 3. For your x-intercept, you're doing reverse, right? So I'm gonna plug in 0 for y. Just like that. Then just solve for x. No, subtract 3, subtract 3. So negative 3 is equal to x. So that's your x-intercept. Negative 3 comma 0. And that's it. That's how you find them. Anything else? Got you. All right. If anything, like come to tutoring, we take a look at it together, you know? It's all good. All right, so let's jump into today's lesson. I'm kind of just picking up where we left off last time, right? So remember we were doing that whole multiplying the exponents, then we add their powers together, and then that was it, right? So we're gonna continue with that, right? We're gonna continue with that. But we were so good at the multiplication, I want to move on to division today. All right. So we're gonna do a little division. So let's start off here, all right? Now we will look at an exponent property for division. As before, we'll try to discover a property by looking at some examples, right? So here's an example real quick. Make that a little bit bigger. So I have x to the 5th power divided by x to the 2nd, right? And I have x to the 2nd power divided by x to the 3rd, right? Let's talk about x to the 5th divided by x to the 2nd. You know that x to the 5th power means what? X times x times x times x times x divided by x to the 2nd, which is x times x, right? What do we do after that? Cross out the like terms, right? Boom, boom. 2 from the top, 2 from the bottom. What's left over? X to the 3rd, right? Flip side, let's solve x to the 2nd divided by x to the 3rd, right? You know that x to the 2nd is just x times x. You know that x to the third is just x times x times x, right? So we're gonna do x to the second divided by x to the third. Cross out the like terms, top and bottom. What am I left with? 1 over x, right? So this is how we divide exponents, right? But there must be some kind of shorter way to do this, right? Let's take a look. Let's take a look. About to give y'all the sauce right now. So notice in each case, the bases were the same and we subtracted the exponents, right? So we see that x to the fifth divided by x to the second is actually x raised to the 5 minus 2 power, or x to the third, right? We see that x to the second divided by x to the third, right, is what you call it? X to the negative 1 power, or 1 over x. So when the larger exponent was in the numerator, we were left with factors in the numerator. When the larger exponent was in the denominator, we were left with factors in the denominator. Notice that the numerator of 1, right, when all the factors in the numerator have been removed, remember, this is really dividing the factors to 1. And so we need a 1 in the numerator. So x divided by x is equal to 1. This leads us to the quotient property for exponents. That's where we at, the quotient property for exponents. Help y'all out a little bit real quick with this. Explain the form a little bit. So the quotient property for exponents. If a is a real number, where a cannot equal 0, and m and n are integers, then a to the m power divided by a to the n power is equal to a to the m minus n power, where m is greater than n. If a to the m power divided by a to the n is equal to 1 over a to the n minus m, where n is greater than or equal to m. Long story short, right? If the power is negative, throw it in the denominator, make it positive. That's all that means. The power is even, right? Leave it alone on top. Let's take a look. Let's take a look. Give y'all a real quick example, real nice. Oops. All right, so let's look at A, right? So for A, I have x to the 9th power divided by x to the 7th power. What does that become? That becomes x to the 9 minus 7 power, or x to the second. That's it. Questions on that? That makes sense? So top minus bottom, that's it. Top minus bottom, all right? Let me change up my color real quick. Let's look at B, all right? I got 3 to the 10 power divided by 3 to the second. What does that become? That becomes 3 to the 10 minus 2 power, or 3 to the 8 power, right? I ain't got no calculator, so I don't know what 3 to the 8 is, but y'all got calculators, I can figure that out, right? All I'm looking for, though, is 3 to 8. I'm not looking for whatever 3 to 8 is. Let me switch it up. Let me switch it up and go with the pink right now, right? So let's look at C. I got B to the 8th power divided by B to the 12th, right? We know that's going to be what? B to the 8 minus 12 power. Call that B to the negative 4 power, right? So now I'm going to let y'all know is we cannot have negative exponents, right? It's illegal for us to have negative exponents. So what do I do with that? I'm going to take it, I'm going to throw it in the denominator, make it positive, right? So it's going to become what? It's going to become 1 over b to the 4th power. And that's it. Yeah? So boom. Let's try that with D. Hold up, I got to change another color. We'll do blue for D now, right? So what about D? I got 7 to the third power divided by 7 to the fifth power. You already know this is going to be what? 7 to the 3 minus 5 power or 7 to the negative 2 power. Because it's negative, throw it in the denominator, make it positive. So it's going to become what? 1 over 7 to the second power. And that's it, right? And of course, I know y'all know that 7 to the second power is 49, blah, 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 whatever. Just looking for this. Questions on this? Make sense? Right. And just throw it in the denominator and make it positive. Yeah. You guys try. So say your name for me again? Excuse me. Hey, say your name for me again? Say your name for me again? Sharon, like with a C? S-H. There you go, right? Gotcha. I'm be another minute, so try this one too as well. Huh? Yeah, do the bottom one. All right, let's go over them. Sorry about that. When you get a chance, try to log into your work for the homework. All right, so let's check this out. For A, right? I got x to the 15 divided by x to the 10. You know what that's going to become? X to the 15 minus 10 power or x to the 5. Everybody got that? Problem? Let's look at B. So I got 6 to the 14 divided by 6 to the 5. This is going to become 6 to the 14 minus 5. Or 6 to the, what's that, 9 power? Everybody good? All right, let's keep going. Let's look at C. I got x to the 18 minus 22 power. Call that x to the negative 4. And then what we going to do? Throw that in the denominator, right? X to the 4, yeah. Okay. Oh, I'm sorry. No, I didn't get down here. I'm coming though. Coming though. Yeah. And then D, right? Very good. It's 12 to the 15 minus 30. Call that 12 to the negative 15. This will be very good. Very good. Questions on this? Anybody? We good? All right. Let's keep it moving. Let's do the bottom. I'm gonna look at A. I have y to the, what's this, 43 power minus 37. Call that what, y to the 6, right? Let me get a different color real quick. Let's look at B. I'm gonna have what, 10 to 15 minus 7. What's that? 10 to the 8, very good. Let me get another color. Try out my red, all right? So I got M, 7, oops, made a mistake. 7 take away 15, and that's gonna give me M to the what? -8, good. And then 1 over M to the 8, very good. And then last, let me get a nice color, let's do black. I got D, it's gonna be what? -19, good. This becomes -11, 9 to the 11, perfect. Questions on this? Anybody? All right, awesome. All right, let's just make a little special note real quick. Little special note. A special case of the quotient property is when the exponents of the numerator and denominator are equal. Such an expression like a to the m divided by a to the m, we know x divided by x is equal to 1, right? So for any x where x is not equal to 0, since any number divided by itself is 1. So long story short, when you have the same thing on top and bottom, it equals 1, right? All right. So the quotient property for exponents shows us how to simplify a to the m divided by a to the m, where when m is greater than or equal to n, and when n is less than or equal to m by subtracting the exponents. What if m is equal to n? When we simplify a to the m divided by a to the m in two ways, in two ways to lead us to the definition of the zero exponent property. So in general, where for a not equal to 0, a to the m divided by a to the m is going to be to lead us to a to the m minus m power, or a to the 0 power. And the same thing, a to the m divided by a to the m is 1. All right? This is going to be an interesting phenomenon. Here it is. Here it is. Please make a note about this. Most of your homework is about this one idea. We see that a to the m divided by a to the m simplifies to a to the 0 power and to 1. So a to the 0 power is equal to 1. So any non-zero base raised to the power of 0 equals 1. Nah, that's not good enough. Hold up. Nah, we gotta highlight that one. That was kind of important. Say it again? Yes, that's exactly what it means. Yeah, it's light, right? Let me say it again. Any non-zero base raised to the power of 0 equals 1. All right? That's like 3/4 of your homework done right there. Have fun typing in 1. But y'all know I like to repeat myself, right? Let's do this again. So I have the 0 exponent property right here, right? So if a is a non-zero number, then a to the 0 is equal to 1. If a is a non-zero number, then a to the power of 0 equals 1. Any non-zero number raised to the 0 power is 1. All right? Gotta remember that. All right. Let's look at this example. I'm just warning y'all, this is really, really advanced. This is really, really hard. All right. I'm gonna look at A. Whoops. Let me get my pen, my fault. A, I have 9 to the 0 power. What's the answer? That's good. You smart. Ooh. I see you. I see you. All right, all right. This is hard now. B. I got n raised to the 0 power. What's the answer? That's what I'm talking about. That's what I'm talking about. That's good. Y'all want to try one or y'all get the idea? Y'all get the idea? Good? All right. Let's talk about something else real quick. It's another situation that could happen. So we want to use a definition of a negative exponent. So we saw that the quotient property for exponents has two forms, depending on whether the exponent is larger in the numerator or the denominator. What if we just subtract the exponents regardless of which is larger? Excuse me. Let's consider x to the second power divided by x to the fifth. We subtract the exponents in the denominator from the exponent in the numerator. We see that x to the second divided by x to the fifth is x to the 2 minus 5 power or x to the negative 3 power. We already know what's going to happen with that, right? We already know what's going to happen with that. But I do like to repeat myself, so I don't mind. Right? We can also simplify x to the second divided by x to the fifth by dividing out the common factors, right? So basically that just means expanding the x to the second, expanding the x to the 5, cross out the like terms, and what are you left with? 1 over x to the third, right? So when in doubt, you can always do that. But there is a trick. There is a trick to this. The like terms. So I have like two x's on the top, 2 on the bottom, they get crossed out. But the last 3 on the bottom don't have nothing else to get crossed out with, so they just remain. So this simplifies, excuse me, this implies that x to the negative third power is equal to 1 over x to the third. And it leads us to the definition of a negative exponent. If n is an integer and a does not equal 0, then a to the negative n power is equal to 1 over a to the n. Let's now look at what happens to a fraction whose numerator is 1 and whose denominator is an integer raised to a negative exponent. Ooh, this sounds fun. Let's check this out. We're taking it back. We're taking it back to a couple classes ago right here with this one. So I got 1 over a to the negative n power. What's going to happen there, right? So we use a definition of the negative exponent. So a to the negative n power is equal to 1 over a to the n. So if I have 1 divided by 1 over a to the n, right? You can do the same thing that we were doing before. Remember, keep, change, flip? Same thing, keep, change, flip. I'm going to keep the 1. I'm going to flip the denominator, multiply straight across. It just equals a to the n, right? Keep, change, flip. Right back at it. I think that was like day 2 over here. So real quick, just to simplify this, just say it, just say the truth out, point blank. This implies that 1 divided by a to the negative n is equal to a to the n power, and is another form of the definition of properties of negative exponents. Okay. Let's take a look at that real quick. So properties of negative exponents. If n is an integer and a does not equal 0, then a to the negative n power is equal to 1 over a to the n. Or if 1 over a to the negative n, right? If we have that, that's going to be equal to just plain a to the n. General formulas right here, general formulas right here. Let's make a special note. So the negative exponent tells us we can rewrite the expression by taking the reciprocal of the base and then changing the sign of the exponent, right? Any expression that has negative exponents is not considered to be in simplest form. So we will use a definition of the negative exponent and other properties of exponents to write the expression with only positive exponents. For example, if after simplifying an expression we end up with the expression x to the negative third power, we will take one more step and write 1 over x to the third power. The answer is considered to be in simplest form and when it has only positive exponents, right? Good stuff, good stuff, good stuff. All right, let's try this out. Also learn. Okay, let's try this out. So for A, right, I got x to the negative fifth power. It's not in simplest form. So what am I going to do? Throw it in the denominator, make it positive. So this is what? 1 over x to the fifth, and I'm done. Questions on that? Good? All right, let's try it again. Let's try it again. So for B, I got 10 to the negative 3 power. So what am I going to do with that? I'm going to just throw it in the denominator, make it positive. It's 1 over 10 to the third. Questions on it? All right, cool, cool. Let's take a look at C. So for C, I have 1 over y to the negative 4 power, which to me is going to become what? 1 over y to the 4. Keep change flip. This becomes what? 1 times y to the 4 over 1. Call that y to the 4. Make sense? All right. Last one, let me look at D. I have 1 over 3 to the negative 2 power, right? Let's call that 1 over 3 to the second. Keep change flip. This becomes 1 times 3 to the second over 1. Call that just plain old 3 to the second. Questions on this? All right, let me let y'all try one. This one was kind of tricky, so. Yeah, that was kind of tricky, so let's try that out. All right, let's try it out. So for A, right, I have Z to the -3 power. That's gonna become what? Is that 1 over what? Z to the third. Perfect. That's 100. How about B? I got 10 to the -7 power. What does that become? Exactly. 1 over 10 to the 7. All right. How about C? I got 1 over P to the -8. What does that become? Good. Now we do keep, change, flip. This final answer is P to the 8. Questions on that? All right, let's keep it moving. I have 1 over 4 to the -3 power. What is that going to become? 4 to the third. Good. Which remember is 1 over 4 to the third. Keep, change, flip, all that good stuff. All right. Suppose now we have a fraction raised to a negative exponent. Let's use our definition of negative exponents to lead us to a new property. So I have 3 over 4 raised to the -2 power. Use the definition of a negative exponent, a to the -n is equal to 1 over a to the n, to give us 1 over 3 to the 4 to the second power, right? And then you know when you square fractions, you just put the power on the numerator and denominator. So I get 1 over 9 over 16, and then keep, change, flip. Final answer, 16 over 9, right? And then, but we know that 16 over 9 is the same as 4 to the second power over 3 to the second, right? So this tells us that 3 over 4 to the -2 power is the same as 4 over 3 to the 2 power. So long story short, you have a fraction raised to a negative power. You flip the fraction on the inside, change the power positive, and then it works. That's it. So to get from the original fraction raised to a negative exponent to the final result, we took the reciprocal of the base of the fraction and changed the sign of the exponent. This leads us to the quotient to a negative power property. Right? So the quotient to a negative power property. If A and B are real numbers where A cannot equal 0, B cannot equal 0, and N is an integer, then A over B to the negative n power is the same as B over A raised to the n power, right? Flip the inside, change the power positive. That's it. For example, for A, I have 5 over 7 raised to the negative 2 power. So what am I going to do? Change the power positive and flip the inside. So that what does that equal? That equals 7 over 5 squared. That's it. All right. If you want to go a step further, 49 over 25, not necessary, but here you go. See, I have B. I have negative x over y to the negative third power. What am I going to do here? Good. This will become what? Negative y over x raised to the third power. Questions on this? You guys try. All right, got it. 2 over 3 raised to negative 4. What does that become? For A. What does that become? Good. Perfect. And if you want to solve it, be my guest. I will take just that answer. B. What's the answer here? We have n over m squared. Good. Questions on this? Okay. So now we have negative exponents. We will use the product property with expressions that have negative exponents. Let's check it out. Who remembers what I do for A? I have z to the fifth times z to the negative third power. Excuse me, z to the negative fifth times z to the negative third. Yes, add them, right? So this becomes z to the negative 5 plus negative 3, which becomes z to the what? Negative 8. But it's illegal for me to have negative exponents. So what do I do with the negative 8? Right, put it over 1, z to the 8. Questions on that? It was a little advanced. You good? All right. So I have m to the fourth, n to the negative third, times m to the negative fifth, times n to the negative second. What do I do here? What does this become? Hmm? Becomes m to the, not square, 4 plus negative 5, and the n, negative 3 plus negative 2, right? Do the math on that. This becomes m to negative 1, n to the negative 5, right? Just adding. But it's illegal for me to have negative exponents. So what does this become? 1 over m n to the fifth power. Questions on that? Good. Let's look at C. I have 2 to the x, excuse me, 2x to the sixth power, negative sixth power, y to the 8, and negative 5, x to the fifth, y to the negative third. What do I do here? What would that become? All right. We multiply numbers with numbers, variables with variables, right? So 2 times negative 5 is what? Negative 10. Then you have x to the negative 6, x to the fifth. Gonna add those together. What do we get? And then what else do we have? Y to the 8, y to the negative third. Let's add those together. Final answer, negative 10, x to the negative fifth, y to the, what's that, 5? It's illegal for me to have negative exponents though, right? So my final answer is negative 10, y to the fifth over x to the second. Questions on, ooh, x to the fifth power, excuse me. Yeah. Questions on this? Good. Uh-huh. Which one? Oh, my fault. It's supposed to be five, right? Shit. So this is -1. This is +1. Whatever, same thing. Whatever. Starting to get complicated, so you guys try. P, Q, V, all of that. Hmm? Or just post it in case you guys want to try it while the lesson is going on. That's fine as well. You have more to do. All right, let's look at A. So I have z to the negative 4 times z to the negative 5. What do I do? Add them, very good. So it becomes z to the negative 4 plus negative 5. Which gives me z to the negative, what's that, 9? Right? But remember though, it's illegal for you to have negative exponents, so I'm gonna flip it. It's gonna become what? 1 over z to the 9 power. Questions on that? Oh, awesome. Let's look at B. B is a little different. All right, so I have p to the 6 with q to negative 2 times p to the 9 times p to negative 9, excuse me, times q to the negative 1, right? What's my answer going to be? Let's start off with the p. What's that going to be? Negative 3, very good. And q to the what? Negative 3, good. But remember, it's illegal for me to have negative exponents. So what does this become? 1 over PQ to P to the third, Q to the third. Questions? Okay. Look at C. All right. Remember, numbers with numbers, variables with variables, right? So I have 3 u to the negative 5 power times v to the 7 times negative 4 u to the 4th power v to the negative 2nd. What should I do first? Sorry? What do you get? What's 3 times negative 4? Perfect. Negative 12. And then I have u to the 5th times u to the 4th, which becomes u to the perfect, u to the negative 1. And then I have v to the 7 times v to the negative 2 power. What does that become? Positive 5, right? Yeah. So v to the 5th power. It's illegal for me to have negative exponents. So I'm going to simplify this. It's going to be negative 12. Ooh. Negative 12 v to the 5th over u. Questions on this? A little advanced. Any questions? All right, let's keep moving. All right, now let's look at an exponential expression that contains a power raised to a power. See, if you can discover a general property, what does this mean? So I have x to the 2nd, which is then raised to the 3rd power. And we know that x to the 2nd raised to the 3rd power is going to be what? X to the 2nd times x to the 2nd times x to the 2nd. And we already know, right? Whenever I have exponents, right, and I'm multiplying, I just add the power. So that's just what? X to the 2 plus 2 plus 2 power, right? Or x to the 6. So notice that the 6 is the product of the exponents 2 and 3, right? So we see that x to the 2nd raised to the 3rd power is x to the 2 times 3 power, or x to the 6 power. So we multiply the exponents. So this leads us to the power property for exponents. Let's talk about it. Let's talk about it. The power property for exponents. If a is a real number and m and n are integers, then a to the m power, which is then raised to the n power, is equal to a to the m times n power. So long story short, whenever you raise a power to a power, you multiply the exponents. Make sense? All right, let's keep it moving. For example, for a, I have y to the fifth power, which is then raised to the ninth power. Whenever you raise a power to a power, you multiply. So what does this become? Y to the 45, right? Right? So 5 times 9. Let's say when you raise a power to a power, you multiply. Let's look at B. I have y to the fifth power, which is then raised to the ninth. Oh, shoot. Sorry about that. I have 4 to the fourth power, which is then raised to the seventh power. So whenever we raise a power multiplies, this becomes what? 4 to the 28, right? That's about it. Let's look at C. So for C, I have y to the third raised to the sixth power times y to the fifth raised to the fourth power. Right? So whenever we raise the power to power, we multiply. So what does this become? This becomes y to the 18 times y to the 20. Right? And whenever we multiply exponents, we add them, right? So this becomes y to the 18 plus 20. That's y to the what? 38 power. Questions on this? No questions? All right. You guys try. Whoops. Okay. Must have ran out of examples for this one. Try that. So I'm thinking about next week, Tuesday. It depends on what we get done on Thursday. homework, test, final. Hmm? Yeah, they're all different. Look on web work, you'll see them. Yeah, you'll see it on web work, yeah. Speaking of Thursdays though, what's happening this Thursday? Good. Entry, Wednesday and Thursday. Y'all go. Get y'all groceries. All right, let's take a look at this. So for A, right? Z to the 6 raised to the 9th power. What does this become? Say it again. 54, okay. Sounds good. B, 3 to the 7 raised to the 7th power. What does that become? 3 to the 49. C, this is what? Q to the 4 times 5, call that 20. And Q to the 9. Put those together. This gives me Q to the what? 29. Good. Questions on it? Anybody? Let's keep moving. So we will now look for an expression containing a product that is raised to a power. So can you find a pattern? Say I have 2x raised to the 3rd power. We know that this is going to become what? 2x times 2x times 2x. Again, numbers with numbers, variables with variables, right? So, excuse me, putting that all together, this becomes what? 2 times 2 times 2 times x times x times x, or 2 to the 3rd times x to the 3rd, right? So we notice that for each factor was raised to a power, and 2x to the 3rd power is equal to 2 to the 3rd times x to the 3rd. The exponent applies to each of the factors. This leads us to the product to a power property for exponents. All right? Good stuff, good stuff, good stuff. All right, product to a power property for exponents. If A and B are real numbers and M is a whole number, right? Then A times B raised to the M power is A to the M times B to the M, right? So to raise a product to a power, you raise each factor to that power, and that's it. Hmm? Nope, they're all different, right? Let's take a look at an example real quick. So let's say I have, like, for example, a -3 mn raised to the 3rd power, right? So -3 mn raised to the 3rd power. What I'm saying is that every single factor, every single term in this is going to get a 3rd power. So this is going to be what? -3 to the third, m to the third, and then n to the third. Put it all together, right? What does this become? 27, m to the third, n to the third. Sorry, -27. Questions on that? Everybody gets the power. That's the lesson. Everybody gets the power. All right. B. What's the answer? Yeah, it is one. So it's open one. Good job. All right. C. I have 6. Try that again. I have 6 to the k to the third power raised to the -2 power. What's gonna happen? Tell me. Close. Everybody gets the exponent of -2. So this becomes 6 to the -2 power times k to the third raised to the -2 power, like that. 6 to the -2 power, we already know. That's going to become what? 1/36, right? And then k to the third raised to the -2 is going to be what? K to -6 power. But you already know negative exponents, you know how that's going to go. This becomes what? 1/36 k to the 6th power. And that's my answer. Questions on that? Good? All right. Let's keep it moving. D. So 5x to the -3 raised to the second. What's going to happen here? Well, everybody gets the power, right? So this becomes 5 to the second times x to the -3 raised to the second. All right? Do the math on that. What's that? 25 x to the -6. Illegal for me to have negative exponents, so 25 over x to the 6. Question on that. All right. No problem. No problem, no problem. We'll catch up, all right? See you. You're welcome. You guys try. Let's take a look. Looking at A. So I have 2 WX raised to the 5th power, right? Everybody gets the power. So this becomes 2 to the 5th, W to the 5th, X to the 5th, right? Y'all got calculators. What's 2 to the 5th? 32. Okay, so final answer, 32, W to the 5th, X to the 5th. Check out B. What's the answer? That's what I'm talking about. So look at C, right? Once again, everybody gets the power. So this becomes 2 to the negative 4 times B to the 3rd raised to the negative 4 power. And 2 to the negative 4 is? So 1 over 16. And then B to the 3rd times, excuse me, not times, raised to the negative 4th power becomes B to the negative 12. You already know, not allowed to have that. So this is what? 1 over 16 B to the 12. Questions on that? Anytime there's a negative exponent, straight to the fraction. But it's not made it possible. Always, always, always. Let's take a look at C. I mean, excuse me, D. I'm sorry. So I have 8a to the negative 4 raised to the 2nd power. Everybody gets that power. It's going to be 8 squared times a to the negative 4 squared. 8 squared we know is what? 64 times a to the negative 8 power, which you already know, that's illegal. So I'm going to have what? 64 over a to the 8 power. Questions on that? Right. So if the power is negative, throw it in the denominator and make it positive. Yeah. Yeah. Hmm? All right, let's keep it moving. Now we will look at an example that will lead us to the quotient to a power property. So let's say I have x over y raised to the 3rd power. We know that that means what? X over y times x over y times x over y. Or we're going to have x times x over y times y times y. Or x to the 3rd over y to the 3rd. So notice that the exponent applies to both the numerator and denominator. So we see that x over y to the 3rd power is x to the 3rd over y to the 3rd. And this leads us to the quotient to a power property for exponents. So bam. So the quotient to a power property for exponents. If a and b are real numbers where b cannot equal 0 and m is an integer, then a over b to the m power is the same as a to the m divided by b to the m. So to raise a fraction to a power, raise the numerator and denominator to that same power, right? So kind of the same idea. Everybody gets the power. In the same case, everybody gets the power, top and bottom, right? Let's try it out. Right? Remember, everybody gets the power, right? So I'm looking at A, and I have the B over 3 to the fourth power. Everybody's going to get that fourth power. So this becomes what? B to the 4 over 3 to the 4. Y'all got calculators. Y'all can figure out 3 to the 4. Right? Looking back at B now, I have K over J to the negative third power. Right? We remember what's going to happen. Everybody's going to get that negative third power. But there was also a property that we learned previously, right? Change the power to positive and just flip the fraction on the inside. So this is actually equal to what? J over K to the positive 3 power, just like that. And keep it simple. Right? Let's look at C. So C, I have 2 times xy squared divided by z raised to the third power. Everybody gets the power. So what does this become? 2 to the third power times x to the third power times y squared to the third power, all divided by z to the third power. Working this out, I should have what? 8 x to the third, y to the 6 over z to the third. Questions on that? Okay. Last but not least, I want to look at D. I have 4 p to the negative 3 over q squared raised to the second. All right? Everybody gets the power. So what does this become? 4 squared times p to the negative 3 squared over q squared to the second. Do the math on that. What do I get? 16 p to the negative 6 over q to the 4. All right? We already know, right? Can't have that negative exponent. So final answer, 16 q to the 4, p to the 6. Questions on that? Uh, 3 times 2 is the same as 2 times 3, so doesn't matter. No questions? Guys, try. All right, let's take a look. All right, looking at A. I have P over 10 raised to the fourth power. Everybody gets the power. This equals what? P to the 4 over 10 to the 4. Questions? All right. Let's look at B. I have M over N to negative 7 power. What does that become? Reciprocal. So I have N over M raised to what power? Right. Positive 7. Questions on that? Okay. Let's look at C. So I have 3ab to the third divided by c to the second raised to the fourth power. Everybody gets the power. So this becomes what? 3 to the 4 times a to the 4 times b to the third raised to the 4 over c to the second raised to the fourth. Put this all together. Woo. What's that? 3 times 2 is 9, 27. What's that? 81, I think. 81. A to the 4, B to the 12, over C to the 8. Questions on that? All right. So let's say 2, 3 seconds. I don't know what just happened there. Okay. Look at D. Again, everybody gets the power. So I'm going to have what? 3 to the third power times x to negative 2 power raised to the third over y to the third raised to the third, right? Let's do the math on it. That's what? 9 times 3, what's that? 27. X to the negative 6 power over y to the 9 power. It's illegal for me to have those negative exponents, so you already know. This is going to be what? 27 over x to the 6, y to the 9. Questions on that? Good? All right. Not gonna lie, this felt like a lot. All right. So we now have several properties for exponents. Let's summarize them, and then we'll do more examples that will use more than one of the properties. So here you go. This is all that we did. It is a lot, I know. So summary of exponent properties. So if A and B are real numbers and M and N are integers, then we have product property, right? So anytime you multiply exponents, you add the powers. Power property. Anytime you raise a power to a power, you multiply the exponents. Cheating. Product to a power, right? Anytime you have a product, like A times B, and you raise it to the M power, everybody gets the power, right? Cheating. Quotient property. Anytime we're dividing exponents, right? We subtract their power. Zero exponent property, anything to the zero power is 1. Quotient to a power property, we have a quotient, excuse me, a over b to the m power. That's going to give us a to the m over b to the m. So same thing, right? Everybody gets the power. We have the properties of negative exponents. So a to the negative n power is equal to 1 over a to the n, and 1 over a to the negative n power is just a to the n. Last, quotient to a negative exponent power. So if we have a over b to the negative n power, that's going to be equal to b over a to the n power. All right. We'll leave that up for a minute. All right, y'all can copy that while I get some water because I got hiccups. Sorry about that. Good night. All these will help you with your homework, all these rules. All right, about to jump into our last topic for the day. Y'all probably noticed already from science class. So we're going to be using scientific notation. All right. So working with very large or very small numbers can be awkward. Since our number system is base 10, we can use powers of 10 to rewrite very large or very small numbers to make them easier to work with. Consider the number 4,000, right? Or like the number 0.004, right? Or 4 thousandths. That's what that is, right? Using place value, we can rewrite the numbers 4,000 and 0.004. We know that 4,000 means 4 times 1,000, and 0.04 means 4 times 1 over 1,000, right? If we write the 1,000 as a power of 10 in exponential form, we can rewrite these numbers in this way. So 4,000, we know is 4 times 1,000. We can also call that 4 times 10 to the third power, right? 0.004, we know is 4 times 1 over 1,000, which we can rewrite as 4 times 1 over 10 to the third power, or 4 times 10 to the negative 3 power, right? You guys also might notice in your calculator sometimes when you type in really large or really small numbers, there might be like something like this, some decimal times 10 raised to a power, or E. Sometimes you might see that E raised to some power as well, right? So when a number is written as a product of two numbers, where the first factor is a number greater than or equal to 1, but less than 10, right? Greater than or equal to 1, but less than 10. And the second factor is a power of 10 written in exponential form. It is said to be in scientific notation, all right? I just want to highlight this real quick because this is important right here. Where the first factor is a number greater than or equal to 1, but less than 10, right? Can't stress that enough for scientific notation, all right? So scientific notation. So a number is expressed in scientific notation when it is of the form a times 10 to the n power, where 1 is less than or equal to the absolute value of a, which is less than 10, and n is an integer. All right. So it is customary in scientific notation to use as the x multiplication sign, even though we avoid this sign elsewhere in algebra, right? If we look at what happens to the decimal point, we can see a method to easily convert from decimal notation to scientific notation, right? 4,000, right, is 4,000 decimal, right after that last zero, right? So if we move the decimal 3 spaces to the left, we get the 4 times 10 to the third, right? Now, for thousandths, 0.004 I'm talking about, right? Start at the decimal, move that 3 spaces to the right behind the 4, right? And then we get 4 times 10 to the negative 3 power, right? And this is how you convert from, like, say, a whole number to scientific notation, and from a decimal to scientific notation, right? Real quick, let me just give y'all a little how-to. Right? So in both cases, the decimal was moved 3 places to get the first factor between 1 and 10. That's another thing. Your first number has to be between 1 and 10, right? Can't be smaller than 1, can't be bigger than 10, right? Wait, 1 and 9. What am I talking about? Between 1 and 9, right? The power of 10 is positive, and the number is larger than 1. So 4,000 is equal to 4 times 10 to the third. The power of 10 is negative when the number is between 0 and 1. So 0.04 is equal to 4 times 10 to the negative third, right? So real quick, a little how-to. So how to convert a decimal to scientific notation, right? Step 1, move the decimal point so that the first factor is greater than or equal to 1, but less than 10, all right? So that means you're moving it left or right, but the first number got to be greater than or equal to 1 and less than 10. Step two, count the number of decimal places. This is the part I hate. Count the number of decimal places n that the decimal point was moved, right? And then step three, write the number as a product with a power of 10. If the original number is greater than 1, the power of 10 will be 10 to the n power. If it's between 0 and 1, right, then the power of 10 will be 10 to the negative n power. And then step four is to just check your answer. And that's how we do it. Let's take a look. So I got two numbers here. So I got 37,000, right? That's y'all future weekly paycheck right there, right? So I want to convert. Damn, let me get my pen. Let me get my pen. My fault. I want to convert 37,000 to scientific notation. Remember, there's a decimal point right here, right after that zero, right? I want to move this 1, 2, 3, 4, right? Spaces to the left, right? I can't stop after the 7 because 37 is bigger than 10. I have to keep going until I get in between that 3 and that 7. So what does this equal? 3.7, right? Forget the zeros, those are not significant. 3.7 times 10 to how many places did I move it? 4 places, right? 10 to the 4 power. That's it. 3.7 times 10 to the 4. Let's look at B. That was A, by the way. Let's look at B. A little bit different, a little bit different. I have 0.0052. Now, I want to move the decimal to a place where the first term, the first number before the decimal is in between 1 and 9, right? It could be 1, it could be up to 9. So I'm just going to move this over 1, 2, 3 spaces, right? So that's going to give me what? 5.2. I'm forgetting the rest of those zeros because they're not significant. 5.2 times 10, and I moved it what? 1, 2, 3 times? 10 to the negative 3 power, right? So if I move it to the left, it's positive. To the right is negative, all right? And that's scientific notation right there. Let me let y'all try one. Of course, in science, y'all probably gonna have some ridiculous numbers. Just trying to get y'all the idea. That's why I'm using these small numbers here. The scientific notation should work in your calculator the same as you typing in the decimal or the whole number out. The calculator should understand both, so that you guys know. All right, let's try this out. Let's try this out. So I got 8, right? I got 96,000, right? What's my answer gonna be? So I heard 9.6 times 10 to the what power? Perfect, right? How do we do that? Decimal point right here. Move that 4 spaces. 1, 2, 3, 4. Right there. There you go. Let me change my color real quick. All right, let's look at B. So I got 0.0078, right? What's that answer gonna be? 7.8, very good. 10 to the negative 3 power. I could tell you a STEM major. That was good. So now, let's look at this. How can we convert from scientific notation to the decimal form, right? So let's look at two numbers written in scientific notation. So I have 9.12 times 10 to the fourth power, 9.12 times 10 to the negative fourth power. So we know that 10 to the fourth is actually 10,000, right? So 9.12 times 10,000, that gives us what? 91,200. That's simple. Just multiply them and you get your answer back out. 9.12 times 10 to the negative fourth power, we know is 9.12 times 0.001. Multiply them together, you get what? 0.000912. That's your answer. So if we look at the location of the decimal point, we can see an easy method to convert a number from scientific notation to the decimal form. So look, I have 9.2 times 10 to the fourth, we know is 91,200. You can take the 9.12, move the decimal point over 4 times, and then that will give you 4 places, excuse me, and that will give you the 91,200. Similarly, right, for the 9.2 times 10 to the negative 4 power, take the decimal and move it 4 spaces to the left, right? And then you get the 0.000912, all right? So in both cases, the decimal point moved 4 places. When the exponent was positive, the decimal moved to the right. When the exponent was negative, the decimal moved to the left, all right? So this is how we go in reverse, how to go from scientific notation to the whole number that we were working with, all right? For those of you that didn't get the notes, I got you. Right? Give you a little how-to. So how to convert from scientific notation to decimal form, right? Step 1, determine the exponent n on the factor of 10, right? So what is that power that we raised in the 10 to, right? Step 2, move the decimal n places, adding zeros if necessary, right? If the exponent is positive, move the decimal point n places to the right. The exponent is negative, move the decimal point absolute value of n places to the left. All right? And then step 3 is just check your answer. All right? We'll go up a little bit. Just tell me when to stop. Okay? All right, good stuff, good stuff. All right? So let's try it out. Let's try it out. So I'm looking at A right now. So I have 6.2 times 10 to the third power. So what do I want to do, right? I want to take, and it's positive 2, right? I have positive 3, right? I'm going to take the 6.3. I'm going to just move that decimal 3 spaces to the right. So 1, 2, 3, right here. So put on some zeros right there, decimal. So I know that this number is 6,300, just like that. All right, let's check out B. Hold on one second. All right, so for B, right, I have negative 8.9 times 10 to the negative 2 power. Now I notice that my power on the 10 is negative 2, so I'm gonna move that to the left, right? Let's check that out. So I have, I'm just gonna write down the 8.9. We'll put the negative at the end, all right? So I have 8.9, and I want to move that 2 spaces to the left. So 1 and then 2, right here. So now decimal point is here, boom, boom, I'm gonna put that negative. So my final answer for this is negative 0.089, right? I need to have that first digit right in front of the decimal. I have to have that at 0 right there. That's a must, all right? So final answer, negative 0.089. Questions on that? Anybody? We good? All right, let's keep it moving. Let's keep it moving. I want to be fair, so let me give you all an opportunity to try. Sorry about that. Mhm. Mhm. 6,300, yeah. Oh, shoot. Right. My fault, my fault. That's my fault. Good eye, good eye. That's my fault. Boom, boom. You're right about that. It's the three, just like came into my head. That's what that was. All right, let's try this out. So I got 1.3 times 10 to the third power, right? This is for A. So, mhm. So what am I gonna do? I'm gonna take that 1.3. I'm gonna move that decimal. How many spaces? Three, right? To the right or to the left? To the right. Right there. One, two, three. Right here. So now I'm just gonna add some zeros. So what does this equal? 1,300. Right? Let me talk about B for a second now, right? So for B, I have negative 1.2 times 10 to the negative 4 power, right? Want to write that in decimal form? So I'm going to start off with that 1.2. And I'm going to move the decimal. How many spaces? Four to the left, right? So 1, 2, 3, and 4 right here. So I have put some zeros right here. Don't forget that negative. So my final answer, negative 0.00012. All right. Any questions on this? No? All right, let's keep it moving. All right, so when scientists perform calculations with very large or very small numbers, they use scientific notation. Scientific notation provides a way for the calculations to be done without writing a lot of zeros. We will see how the properties of exponents are used to multiply or divide numbers in scientific notation. All right? So I'm gonna keep it a little bit simple with y'all. We're just gonna do the multiplication. But if you guys apply the rules of exponents to the division of this, you can do the same thing. But we're just gonna go through the multiplication together. So, well, actually, no, we're gonna get to do division too. Yay. Never mind. So multiply or divide is indicated, right? So write the answers in decimal form. So let's do this. For A, I have negative 4 times 10 to the fifth power times 2 times 10 to the negative 7 power, right? Okay, let's multiply those whole numbers, right? Negative 4 times 2 is what? Negative 8, that's what I'm talking about, right? Times 10 raised to what power? What is that? Negative 2, now we're talking, right? So the same exponent rules, right? When we multiply the exponents, we're going to add their powers. So 5 plus negative 7 is negative 2. All right. But they didn't want this answer, though. They wanted a decimal, right? So what do I have here? I have an 8. Decimal point is right there. I'm going to move it 2 spaces where? To the left or to the right? To the left, right? So move this to 1, 2 right here, right? So what's my final answer? My final answer, negative 0.08. That's it. Questions on that? Good? All right, let's keep it moving. Let's try B. So happy about B. I thought we weren't going to get to do this. So 9 times 10 to the third power divided by 3 times 10 to negative 2 power, right? So let's do the numbers real quick. 9 divided by 3, what's that again? 3, right? So this is going to become 3. And then now when I divide exponents, what do I do? Subtract them, right? So this is going to be what? 3 times, oh Lord, why are you not writing? Give me 1 second. All right, here we go. Sorry about that. Sorry about that. Let's try it again. 3 times 10 to the, we'll subtract them, right? So what's it going to be? Say it again? Not 1. Remember, top minus bottom. What is it? 5. Now we're talking, right? So that becomes 10 to the 3 minus negative 2 power, right? And we know 3 minus negative 2 power, it's going to be a negative on the negatives are positive, so this becomes 3 plus 2, so that's why we get the 5, right? Anyway, they didn't want this answer, right? They wanted it in like a whole number form, right? So I have a 3 with a decimal here, right? And where am I going to move that decimal? Left or right? To the right, right? We're gonna move in 5 spaces. So I got 1, 2, 3, 4, and then 5 right here. So that's gonna be boom, 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 boom. That's one right here. So what is this? This is 300,000. Awesome, awesome, awesome. This makes sense how to multiply and divide them? Let me let y'all try one. All right, let's take a look. So I'm looking at A real quick, right? So I have -3 times 10 to the fifth power times 2 times 10 to the -8th power. So I want to multiply those numbers first, right? So -3 times 2, what's that? -6, right? Times 10 raised to what power? Right? -3, right? Very good. So now, remember, they don't want this answer. They want it in decimal form, right? Good. Moves over 1, 2, 3. So final answer is -0.006. There we go. Let's look at B. So B, I have 8 times 10 to the second divided by 4 times 10 to the -2. Let's divide that real quick. 8 divided by 4 is what again? 2 times 10 to the what power? 4 power. Very good, right? But again, remember, they don't want this answer. So this is going to be 2. This over 4 times. 1, 2, 3, 4. So I have what? 1, 2, 3. Right there. 20,000. Damn. All right. Questions on this? Anybody? We good? All right, bet. So, just want to repeat, pantry on Wednesday and Thursday. Y'all should really go. All right. That's all I have for today. But if y'all want to stick around, do your homework, please. All right. We got like 15 minutes left if y'all want to do some homework questions. All right. To those of you watching recording, have a good night. See you guys on Thursday.